Okay, so we are going to perform selection sort. I have taken some elements in this array, and let's take the size of this array as n. You can clearly see that the elements in the array are not sorted. Initially, what we are going to see that the left portion of this array is sorted and the right portion of this array is not sorted. Okay, so we are going to sort the elements in this array step by step. At first, I would sort the element at the first position, then I'll sort the element at the second position. So I would keep on doing the sorting until the last element is sorted in this array. By performing selection sort, we simply pick the smallest element from the array. We pick the smallest element from the array and put that smallest element to the starting position of the array. That means to the correct position of the array, so that this array gets sorted. We perform number of steps, or you can say we perform steps or rounds, you can say, or from number of passes, okay, to sort the element. We would be sorting each element of this array at every step. So I have taken passes. Okay, you can take whatever round or step or passes. Okay, so at the first pass you can say, let's write the element of this array, then we are going to sort the element at every step. This is what the selection sort. So we have to select the element and sort the element one by one. So let's write the element over here: 5 6 8 7 1 4. So in this array you can clearly see 1 is the smallest element in this array. So what we are going to do in the selection sort, we are going to pick that element and put that element in the first position, or you can say the correct position of this array. So the result would be, if I place the element, the smallest element, to the first position, let's take the first position as I. Okay, so in the first position, if I would put the smallest element, then it would be 1 6 8 7, and this 5 would be to this place. Okay, so this is the pass one, or you can say the round one. You can clearly see the first element of this array is sorted, and now the rest, all the elements of this array is not sorted. So we will perform the same selection sort technique to sort all these elements one by one. So in the next step, what I would do in the next step, pass 2. Okay, and okay, so this would be passed. In the next step we can see that this whole part is not sorted and this part is sorted. So now we will sort the element which is at the position I is equals to 1. So we are going to sort the element which is at the position I is equals to 1. We are going to write this element 1 6 8 7 5 4. Going to sort this element of this array with these elements, whatever the minimum value in this array would be, that would get into the position of I is equals to 1. That means at I is equals to 1 we will place the smallest element of this unsorted array. Okay, so what would be the result of this array? 4 is the second smallest element of this array. So what the result would be? 1. I'll place this number over to this place. That means 1 4 8 7 5, and this 6 would be at this place. Okay, so we have swapped the second smallest element of this array. So now you can clearly say that these two elements are sorted. Now we have to find the third smallest element of this array by doing the selection sort. We have to perform the same technique again and again to sort this array. So at the third pass, I will write the same array 7 5 6 7 5 6. Now we are going to sort the element which is at the position I is equals to 2. This was I is equals to 1. This is I is equals to 2. In this whole part, that means in this whole part, including this, okay, including this, in this whole part, we can clearly see that 5 is the smallest element. 5 is the minimum value in this unsorted part of this array. What would I do? I would simply pick that element and place that element over to this place at I is equals to 2. So the result would be 1 4, and after placing this element 5, 1 4 5 7, and 5 would be replaced by 8. So this is this. So we have sorted till here. You can clearly see that the elements which are at the left position of this bar are sorted, and the element which are at the right position are not sorted. We are going to sort the rest 3 element of this array. So we have performed 3 passes. And we have sorted till this place of this array. Going to perform same technique until every element of this array are sorted. So let's take the value, let's write the value 1 4 5 7 8 6, and now the I would be at this position. Okay, I is equals to 3. Now we will check the smallest element of this array from this position to this position. The smallest element of this unsorted array is 6. So we are going to pick that value and place that value at this position. So the result would be 1 4 5 6 8 7. The element which are at the left position are sorted till here. Okay, all those elements are sorted at pass 4. Only two elements are left in this array. So we will perform the same thing. Okay, one by one. Pass 5. At pass 5 we can see we'll write the same element 1 4 5 6 8 7. Now at the position I is equals to 4. Now at the position I is equals to 4, I will perform the same thing, and you can clearly see that I is equals to that means the element 7 is the smallest element comparing 8. So I will, the result would be 1 4 5 6 7 8. And at the last position you can see, every elements are sorted. In the after sorting this element, we can clearly see that all the elements in this array are sorted. Okay, so in this whole selection sort steps what we have performed till now, at elements, how many elements are there in this array? There are 1 2 3 4 5 6. There are 6 elements in the array, and we have performed 1 2 3 4 5. We have performed 5 passes. Okay, there are 6 elements in this array and we have performed 5 passes. Number of steps that are going to be followed in this whole selection sort would be the size minus 1, whatever the size would be. Okay, if the size is 8, so the number of steps would be followed would be 8 minus 1, that means size minus 1. So these are the steps that would be followed to sort the elements in the array by using selection sort. Now let's write the code for this, for the selection sort. We have seen the explanation. Now we are going to write the code to check how selection sort works. Okay, so after performing code, your concept would be more clear. This is the outer loop. We will run an outer loop for I, which would be for the sorted array. We will run j, another loop j, that would be for the unsorted array. Let's write the code, that would be more clear. For I is equals to 0, I less than n minus 1. I will explain why I have taken n minus 1. Okay, I plus plus. So in the previous step we have seen that we have performed 5 steps. In the last step we have seen that when I have reached till I is equals to 4, I found that every element of this array is sorted. At I is equals to 4, we have seen that largest element is placed at its correct position. Okay, so we don't, if I have 8 elements, okay, if I have 8 elements and I have sorted till 7 element, then the 8th element would be sorted at its own. Why? Because we have seen that every elements are sorting step by step. So if we have sorted till n minus 1 position, then the nth position would be sorted by its own. Okay, if we are running the first loop till n minus 1 and we are getting all the elements sorted at its position, so we don't need to perform that extra step. Okay, why to run till I is equals to 5 if the elements get sorted at I is equals to 4? Did you get me? Why to move till this position if the elements are getting sorted till this position only? Okay, so we have taken this I less than n minus 1. What it means that if n is equals to 6, that means 6 minus 1 is equals to 5. So I would be less than 5. So it would run till 4. Okay. In this loop, you can see that I is less than n minus 1. It is not less than or equals to. Okay. I is less than n minus 1. It would run till 4th position. The I would run till 4th position. So in the explanation of selection sort, initially I have told that at I is equals to 0, we will assume that this is the minimum index. Okay. This is the minimum index. We will write the int minimum is equals to I. That means your minimum index is this. For now, you are going to store the minimum value at I. Okay, you have assumed that minimum value is I. It is not fixed. The minimum value can be changed. Okay, later on when we will traverse in this array and we will find the smallest element, then this minimum value can be changed. So for now we have assumed that the minimum index is this. So let's write the code for this unsorted array. So this code would be for int j is equals to I plus 1. I have told you earlier about this thing, why we are taking this. So this I plus 1 is basically coming from this position. This position would be I plus 1, because after sorting this element, okay, now we have seen in the selection sort, after sorting this element, we are searching the minimum value from this part of the array. Okay, after sorting this, we are searching the element from this part of the array. After sorting this, we are searching the element from this part of the array. That means after sorting this part of the element, we are going to search the minimum element from this position. That means if this is I, then we are going to search the element from this position, which is equals to I plus 1 till the last element. Okay, till the last element. So I have written this loop for that. Now we will check the condition if ARR of j is less than minimum value. Okay, if this ARR of j is less than minimum value, that means here you can see that if ARR of j is less than the minimum value, that means if any element of this array is smaller than this element, then what we will do, we will replace that minimum value with this number. Initially we have assumed that minimum value is equals to I, though we can clearly see that 5 is not the minimum value of this array. Okay, initially what we have done, we have assumed that minimum value is equals to I, what we have written. After finding that if ARR of j is less than ARR of minimum, that means if any element of this unsorted part of the array is smaller than this value, then what will I do? Then I will simply change the minimum value with that j. So what we are doing, we are simply changing our minimum value in this step. After checking this condition, what we have seen that which is smaller than this element, that would be our minimum index of this array. Okay, so our next step would be, okay, so this is our final step. Okay, this is our final step. In the final step, what we can see is, initially what we have done, initially we have assumed that minimum value is I. We have not taken this as fixed value. Okay, so this we have assumed that the minimum value would be I. Okay, and after finding this condition, what we have found that j is the minimum value. If j is minimum value, then what we will do, we will simply replace that I with j. From now, j would be our minimum value if this condition satisfies. If this condition satisfies, then j would be our minimum value. Okay, and in the last condition, what we can say is, if minimum is not equals to I, that means if minimum is not equals to I, which says that if minimum is equals to j, then what we will do, we will simply swap this minimum value with the I. Okay, we will swap this minimum value with I. Now let's try run this code and understand how this code performs in the selection sort. So let's check every statement and understand how this selection sort works. After sorting the first element, we are taking this j is equals to I plus 1. That means after sorting this first element, we are finding the smallest element from I plus 1 till the last element of this array. Okay, so we are searching from this part. Okay, we are searching from this part, So this loop says that, and we are searching from I plus 1 till the end element of this array. Okay, the third statement says that we are going to check a condition where we will find our minimum value. Initially we had assumed, but we are going to find the minimum value by this condition. The second condition says if minimum is not equals to I, if minimum value is not equals to I, then we will simply swap this minimum value. Now the minimum value has been changed with j, so we will swap this j with ARR of I. We will swap this j with I. Okay, now the smallest element would be this after finding this condition. Okay, let's dry run and check this condition, how it performs, how the sorting works in the selection sort. So in the first step we have seen that 5 6 8 7 1 4 it was given. Now in the first step, what we have done, we have selected the smallest element and put that smallest element at the first part. Okay, that means we have checked this condition, and now our minimum value has been updated. In the condition, it says if ARR of J is, if array of J is less than array of minimum. So till here minimum value is I. Okay, till here minimum value is I, which is, this is I. Okay, this is I, and this whole part is J. Okay, this is I and this whole part is J. So what this condition is saying is that if array of J is less than array of minimum, that means if any element of this unsorted part of the array is smaller than the minimum value, then what we will do, we will simply change our minimum value. In this example, you can clearly see that array of J, which means from here to here, this part is smaller than this element, which is this. Okay, this is the minimum value. So this is smaller, this part is smaller than this value. So what we will do, this condition is satisfied. So what we will do, we will change our minimum value to J. So in this condition, we can see that the minimum value is not equals to I. Minimum value has been changed with J. So this minimum value is basically J. So we can see that J is not equals to I. J, which is this, is not equals to I. So what we will do, we will simply swap this element. We are performing the last step, which says that we are simply going to swap this ARR of minimum with ARR of I. Now this ARR of minimum is J. Okay, initially it was I, now it has been changed with J. So we are simply swapping this element with this element. So after performing the pass one, we have found this result. That means we have swapped this value from 5. 5 has been shifted to this position and every element is at its own position. So this is the result after passing the first condition. Okay, let's check the second condition. Let's check the second condition. In the second condition, we can clearly see that now our I is equals to 1. I would be here at 1. Okay, now we will run the loop. We will run the loop from J is equals to this position to this, which is I plus 1 till n. So in this loop, we are going to follow the same steps. We are going to check whether ARR of J is less than ARR of minimum. If ARR of J is smaller, then we will simply what we will do, we will simply change the value of minimum with with J. Okay, and we'll check this condition. Then if this condition satisfies, then we will swap the element. And here you can see that 4 is smaller than this element 4, which is J. 4 is smaller than this element, so we will simply swap this element with this. Okay, so the result after second pass is this 1 4 8 7 5 6. So we have switched this position. Now we are at I is equals to 2. In the third pass, we are at I is equals to 2. So we will check the same thing. Okay, we will check the same condition if ARR of J is less than ARR of minimum. If this ARR of J, any element of this part of the array, of this unsorted part of the array, is smaller than this element. So now we will check the same condition. If any element from this unsorted part of the array is smaller than this element, then we will simply swap that value. We have swapped it. In the fourth condition, we can see that now we have sorted till this position I is equals to 2. Now we will check the same condition for I is equals to 3. We will check the condition for 7 from this unsorted part of the array. Okay, so we can clearly see, okay, 6 is smaller than 7. So which says that ARR of J is less than ARR of minimum. Okay, ARR of J is less than ARR of minimum. So we will simply, what we will do, we will simply swap this element from this. After this pass, we have sorted the element till I is equals to 3. Okay, and now we are left with 2 elements only. Okay, so in the last part, we can clearly see that this element is smaller than this. Okay, we have run the loop till this. Now we are running the loop from till this. Okay, this is our I. Okay, this is our I, this is our J. J is equals to the end of the element. Okay, so we will simply swap this element, okay, because we can find that 7 is smaller than this element. So after finding this element, we will swap this element from this number. Okay, and the last element is already sorted. If we are sorting till n-1 step, then the last element would automatically sort it. Okay, so this was the selection sort. So these are the conditions. So these are the condition where how selection sort works. Okay, so now we are going to check the time complexity of this selection sort. In this steps, we have seen that to sort the first part of the element, in this array, we have to make the comparisons from this part to this part, okay, leaving this part of the array. So in the selection sort, At each step, when we are sorting any element, we are comparing the elements. We are finding the smallest element from this part of the array. Okay. So at each step, you can see that if I have sorted this element, to find the smallest element at this position, we are making the comparison from this part to this part. Okay. We are making the comparison from this part to this part. So at each step, after sorting the elements, we are making the comparisons from the next element to the end of the elements. Let's suppose we have n elements in the array. We narrow the comparisons at each steps. What we have seen that if we have n elements in the array, so we are making the comparisons n minus 1. In the next step, we are making the comparison till n minus 2. In the next step, we are making the comparison till n minus 3, and so on. We are going to compare the elements until we are left with one elements in the array. Okay. So after arranging these comparisons, what we can find is 1 plus 2 plus, I'm writing this in the reverse order. So 1 plus 2 plus 3 plus 4, n minus 3, n minus 2 plus n minus 1. Okay. So we are making the comparison from n minus 1 to 1. So the mathematical calculation for these expression would be n into n minus 1 by 2. So you already have done these type of calculation in 6th or 7th. Okay. So this is basically the expression of summation of numbers. Okay. So we have summation of numbers 1 plus 2 plus 3 plus 4. So we have summation of number 1 plus 2 until n minus 1. Okay. So the mathematical calculation for this expression would be n into n minus 1 by 2. So after calculating this value, we will get n square minus n by 2. Okay. N square minus n by 2. So after making these comparisons, what we have found this mathematical expression. Okay. After calculating this mathematical expression, what we will find? We will find n square minus n by 2. To find the time complexity, we check for the higher order in the mathematical expression. So the higher order in the mathematical expression is n square. Okay. So our time complexity would be O of n square. Now let's check the conditions of best case and worst case. Okay. So in the best case, what could be the possible scenario? That every element in the array is sorted. So let's check this condition. Okay. Here what we have found that the elements are sorted. In the best case, if this is the scenario, so what we do in the selection sort, we are still going to check the elements which are at the first position, and we are going to compare the smallest element from this rest part. We are going to perform the same selection sort technique or same steps what we have done earlier in this unsorted part of the array. Okay. Though st though we can see that these elements are sorted. Okay, these elements are sorted, but in the selection sort, we are going to check the value at each step. Okay. So still we are going to make the same number of comparisons in the selection sort. So in the best case scenario, the time complexity would be O of n square. Okay. And now to check the worst case scenario, so our elements would be arranged like this. That means the higher element would be at the first position, the lowest element would be at the last position. So this is the worst case scenario that can happen in the selection sort. So in the worst case scenario, still you are going to make the same number of comparison to sort the elements at each step. So the time complexity at the worst case would also be same as n square. Okay. So in the best case, we have seen that the time complexity is going to happen n square. In the worst case is also the time complexity would be n square. So these are the time complexity of selection sort. So now I hope that you have understood the topic selection sort, what is the time complexity and how selection sort works. Okay. And we already have checked the codes. So that was all for the selection sort.